Hello everyone, and welcome to the second video in our linear functions unit. Today we're going to look at slopes of parallel lines and perpendicular lines. Let's begin with some of the basics that we'll need for this lesson. First of all, parallel lines have equal slopes. Notation-wise, we can just write it like that. M1 equals M2. Reminder that M represents slope. If we look at a graph, what that means is that if I have a line here, and let's say it has a slope of 6, then something that is parallel to it must have the exact same slope. So this will be 6 as well. So this would be the slope of line 1, this is the slope of line 2. And now why they have to be equal? Well, if they weren't equal, that means they'd be going at different angles, so eventually they would cross. So the only way they will never cross would be if they have the exact same slope. And remember, never cross, that's basically the definition of parallel. These lines will never cross. All right, so parallel lines have equal slopes. The second thing we're going to look at is regarding perpendicular lines. Lines that are perpendicular have slopes that are negative reciprocals of each other. Okay, so that's some heavier language, negative reciprocals. So first of all, reciprocal, if we look at that, actually even before I do that, let's just look at the notation here. This shows you reciprocal. So you can see here that I'm saying that this slope of line 2 is equal to the reciprocal of the first one and then made negative right there. So remember with reciprocals, if I give you something like 2/3, the reciprocal of 2/3 is 3/2. So reciprocal is just when you flip that fraction. One more, so if I said I have 1/5, the reciprocal of that would be 5/1, and you might choose to write that as just 5. Negative reciprocal just means to change the sign. So a negative reciprocal, some examples could be with the same 2/3, I'd flip it, so 3/2, and change the sign, meaning now it's negative. If I had something like that, negative 2/7, I would first of all, I'd flip it, so now it's negative 7/2. And then I have to make this thing negative again. So now I have two negatives. That's going to equal positive 7/2. And you can see that the whole negative idea just changes the sign. So originally it was negative. Now you don't write it down, but there's your positive sign. So they're negative reciprocals of each other. And what that would look like with a graph. So if I say this one is 4/5, then here comes a perpendicular line. Its slope would have to be, well, first of all, you can see it's got to be negative because it's going down. And then it would be 5/4. Remember, perpendicular, that means that that these two lines meet at 90-degree angles. So that's 90 degrees right there. So two lines that meet at 90 degrees, their slopes have to be negative reciprocals of each other. All right, let's look at an example with this. Determine if the lines are parallel or perpendicular. So line EF passes through point E, -4, -3, and point F, 0 and 3. Line PQ passes through P and Q. Line RS passes through that R and the S. And then we're wondering in the end, are these lines parallel, perpendicular, or neither? So, seeing we have some graph paper, I'm going to actually draw this out. The first thing we'll need to do to consider if something, or to determine if something's parallel or perpendicular or neither, you got to look at the slopes. So to remember to find slope, you can either, if you have a picture, you can use rise over run. If you only have points, you can use a 2-point slope formula. In this one, let's just practice graphing our lines again real quick to give ourselves a picture. So EF, -4, -3, so this is -4. F, 0, and +3 is right here. There's my line, so that's EF. So the slope of line EF, I'm going to use rise over run. I technically didn't need to. I could have used my 2-point slope formula because I have 2 points, but I have this piece of graph paper here, so it's pretty quick just to draw it, because the rise over run is actually a faster method if you have the picture. So the rise, it's going to go 1, 2, 3, 4, 5, 6. I'm rising 6, and I'm running 1, 2, 3, 4. So my slope is 3/2. Okay, so I've got line EF covered. Let's look at the next one, line PQ. So P is -3, -5, right there. Q is 2 and 3, 2 and 3. And draw my line. Whoa, that was not a very good line, people, I drew, but I'll have to do the trick. So because my line is so bad, It's kind of tough to see if this is parallel or not, because if it's parallel, it'll be equal distances apart or an equidistant from each other. Let's not worry about checking that out. I guess I could actually put my P and my Q, put my letters on there. So this is P and Q. And again, we're using rise over run. The rise, it looks like it goes up 1, 2, 3, 4, 5, 6, 7, 8. The run, 1, 2, 3, 4, 5. All right. So that is the slope there. We're going to consider, or we're going to calculate all the slopes, and then we'll look at them and compare them to each other. RS, let's do it. R, 0, negative 3. S, 4 and positive 3. Let's see if I can do a better line. That is better. Okay, let's consider, or let's calculate it. That's RS, rise over run. You don't have to write the formula down each time. Formulas just help you determine the logic that's required for a question, so like the thinking involved. And if you've got the formula memorized, then you've already got the thinking down, so you don't have to write it down if you don't want. My rise, 1, 2, 3, 4, 5, 6. The run, 1, 2, 3, 4. All right, and that's going to work out to 3 over 2. So now let's start wondering about things. So if they're parallel, slopes should be identical. So if I look for these slopes here, I can see I have 3 over 2 and 3 over 2. So I know that EF is parallel. Now for parallel, you can just draw a set of parallel lines instead of actually writing out the word parallel. So I know that EF is parallel RS. Now, maybe there's parallel lines and there's perpendicular lines. Well, if I look at the actual graph itself, there can't be anything perpendicular because perpendicular involves two lines crossing. Those lines aren't crossing, okay? And the third option was neither. So I guess PQ is neither parallel or perpendicular to the other two lines. We don't need to write that out, but just to kind of finish our thought. Okay, let's look at another example. B. Again, I have 2 points, so I could just use 2-point slope formula, or I could graph it. Why don't I switch things up this time and go 2-point slope formula? So let's pick a color here. So the slope of AB, y2 minus y1 over x2 minus x1. And I'm going to hopefully show you that this really wasn't any faster in this case because I have a nice piece of graph paper down there. It doesn't take me long to plot the points, and rise over run is super fast to do. So this is x1, y1, x2, y2. So I get 1 minus 4, 4 minus 0. 1 minus 4 is negative 3. 4 minus 0 is 4. So there we go. There's my first slope. The second slope, that's going to be CD. So x1, y1, x2, y2. I forgot to finish writing out my formula over here. Use my open brackets. Again, the reason I do that is to really highlight those sign changes. Okay, so y2 is 4, y1 is negative 2, x2 is 3, x1 is 0. I have a sign change over here, 4 plus 2, so that's 6. 3 minus 0 is 3. I've got 3 there. Now I start to consider these lines. One thing you would have noticed if we graphed it is that they must be crossing because I have one negative, one positive, but they're not negative reciprocals of each other. The negative reciprocal of this one, negative reciprocal, would have been equal to, well, I have to, the negative reciprocal, so first of all I have to flip it, so I get negative 4 over 3, and then my two negatives make a positive. So line CD would have needed a slope of 4 over 3 in order for me to consider these things perpendicular. So you can, again, if you're given the points, you can use a 2-point slope formula, or if you have a nice piece of graph paper, coordinate plane right there, it's likely quicker just to plot the points and use rise over run. So in summary, how you can determine if two lines are parallel or perpendicular, calculate the slopes individually, then compare the slopes. Remember, equal is parallel, and if they're opposites, which is negative reciprocal, that would be perpendicular. Let's look at another example. Identify a line parallel or perpendicular to a given line. Okay, so in A here it says determine the slope of a line that is perpendicular to a line through GH. Okay, so to know if something's perpendicular, we need to figure out what the initial slope is, because once we know the initial slope, then we can determine the negative reciprocal of this perpendicular line. So I have slope GH, y2, x2 minus x1. I'll work sideways here, just because I don't have as much room. All right, x1, y1, x2, y2, negative 2 minus 3, 1 minus 2. Got a sign change there. So negative 2 minus 3 is negative 5. And then 1 plus 2 is 3. So my first step is finding that given slope is negative 5 over 3. I need to find the slope of a line that's perpendicular to it. So for perpendicular, I got to figure out that negative reciprocal. So if I have negative 5 over 3, that's going to be negative the reciprocal of that, which is now negative 3 over 5. Two negatives make a positive. So the slope of a perpendicular line would be 3 over 5. Now we're going to determine the coordinates of J, so that line GJ is perpendicular to this line GH. Now what that means is line GJ will intersect line GH at point G. That seems pretty wordy, so why don't we draw a little bit of a picture just to kind of see what's going on. So my Cartesian plane. So I'm dealing with GH, so why don't I actually plot those? So negative 2 and positive 3 would be 1, 2, 1, 2, 3, somewhere around there. The other one, that's now would be 8, would be 1 and negative 2, so 1 and negative 2, so here. So we have a line here, and then they're talking about another line J, so that it's going to meet. So here is line G, and then this ends up being 8. They want to find another line that will intersect GH. So we're looking for a line that's going to go through G. We're going to have this point J somewhere. I don't know where J is. Okay. It's going to meet so that it, meets at a 90-degree angle. So that's what we're looking for, this J coordinate. So determine the coordinates of J so that GJ is perpendicular. What we can do on this is remember that slope is really, or not as really, but slope can also be interpreted as just the direction between 2 points. So if I know my coordinate G, which I have there, then I can just use the slope I have, because for GJ, this is going to tell me to go up 3 from here, 1, 2, 3, and then over 5, 1, 5 to get to the new coordinates. Now, unfortunately, I drew that kind of messy, so I'm not sure if that works so good. But we can just kind of think about it. If I have my point G and the coordinates were negative 2 and 3, this point J is what we're going to kind of consider. Oh, sorry about that. It says I'm going to go up 3. So to go up 3 means that we're going to actually increase our y. So that should be up to 6. And then we're going to run 5. So I want to actually add 5 to this. So it should be 3, 6 is where I end up being for the coordinates of this new point. So if I drew this, I'm going to use red here. I go up 3, you said. 1, 2, 3. That makes, we were at 3 before. So it makes sense we're at 6. Now I want to add 5. So it actually, I'm at negative 2. So they go negative 1, 0. 1, 2, 3. And that'd be my 5 movements. And you can see that's what my 3 is. So both of these definitely do work out. You can use the visual, or you could use my little trick down here. Remember, it all came from my perpendicular slope. So in summary for this, to determine the unknown slope of a line that's parallel or perpendicular to a given line, find the slope of the first or given line, and then use that first slope to calculate the unknown parallel or perpendicular. Last example. I am wondering, is this triangle ABC a right triangle? So you can notice I forgot the letters A, B, C. And we're wondering if this triangle is right. So remember, a right triangle is a triangle that has a 90-degree angle in it. All right? And where the 90-degree angle would be is right here. So truly what we're wondering is, in other words, is AC perpendicular to CB? Okay? Now that we know about their perpendicular slopes, really what I'm wondering is, are these two slopes negative reciprocals of each other? How would I find that out? Well, simply by calculating. So I need to find the slope of AC, and then I need to find the slope of CB, or BC. I could have wrote. Typically, I write things in alphabetical order. So rise, run. Remember to work on the leftmost point. So I want to work from A here when I'm dealing with AC. I'm going to go down 1, 2, 3, 4, 5. So -5. And then my run, 1, 2, 3, 4, 5. So slope of -1. So now we'll go to CB, rise over run. Again, start on your leftmost point. So now with CB, I'm going to start here. And it looks like I'm going up 1, 2, 3. And my run, 1, 2, 3. So it equals +1. So now, are these negative reciprocals of each other? And if I take -1, the negative reciprocal of that, so I guess it'd be -1 over 1. The reciprocal would just still be -1 over 1. And then the two negatives make a positive, so I just get 1 over 1, or 1. So the negative reciprocal of -1 is +1. Therefore, AC is perpendicular to BC, and triangle ABC is a right triangle. Okay, that's everything I have to cover in this lesson. If it doesn't make sense, make sure you go talk to your teacher or come find me. Have a great night, everyone.